So now guys, in this video we are going to learn about Otto cycle, diesel cycle and dual cycles according to SSC JEE syllabus. So let's start our video. So as you can see here, this one is an Otto cycle, and this graph is between pressure and volume. Here this one is the top dead center and this one is the bottom dead center, and this volume is called as specific volume or swept volume, and before TDC this called as clearance volume. Here step 6 to 1 is called as suction stroke, as I already tells you about that, about 4 stroke engines. So 6 to 1 is called as intake. As you can see here, point 6 to 1 is intake, and point 1 to 2 is isotropic compression. As you can see here, this one is isotropic compression, and point 2 to 3 is called as constant volume heat input. So guys, in Otto cycle we are getting constant volume heat input, and point 3 to 4 is called as isentropic expansion, this one. And now point 4 to 5 we are getting blow down, and point 5 to 6 is called as exhaust, and we are getting heat output here and heat input here. In cycle 2 to 3 we are getting heat input, and in cycle 4 to 1 we are getting heat output. So now let's see how we can calculate the efficiency of Otto cycle. So we can calculate efficiency of Otto cycle by using this formula: W net work net per unit heat input is equal to 1 minus Q output upon Q in. And we can write Q out because in 4 to 1 we are getting heat output, and in 2 to 3 we are getting heat input. Then we can write 1 minus CV T4 minus T1, because this cycle is in constant volume, so we will use CV, specific volume, sorry, CV, because of this constant volume. Then this CV will be cancel out. Then we will get formula of efficiency for Otto cycle: 1 minus T4 minus T1 upon T3 minus T2. Now if we will take T1 common from here and T2 common from here, now for isotropic compression and expansion strokes, and recognizing that volume at point 1 and point 4 is same, and volume at point 2 and point 3 are same, because these are the constant volume process. So after that we can write this equation as T4 by T1 is equal to T3 by T2. Now if we will take common T1 from here and T2 from here, then we will get T4 by T1 minus 1 is equal to T3 by T2 minus 1, and now we can cancel out. Then we will get the efficiency of Otto cycle as 1 minus T1 upon T2 with the help of graph. Now the thermal efficiency of Otto cycle depends only on compression ratio and specific heat ratio. So remember guys, thermal efficiency of Otto cycle depends only on compression ratio and specific heat ratio, because in a multiple choice question in SSC JEE they can ask. And now let's see diesel cycle. So fuel is injected into the combustion chamber very late in the compression stroke. Due to the ignition delay and the finite time required to inject the fuel, combustion lasted into the expansion stroke, and this keeps the pressure at peak level well past top dead center. And the combustion process is approximated as constant pressure heat input in an air standard cycle. So let's see this cycle, air standard diesel cycle graph between pressure and volume. Then we will get this graph. Here we are getting heat input at constant pressure and heat output as constant volume. So how we can calculate the efficiency of diesel cycle? So let's calculate. So here as you can see, process 6 to 1 is constant pressure intake, process 1 to 2 is isotropic compression stroke, and process 2 to 3 is constant pressure and heat input. Process 3 to 4 is isotropic power or expansion stroke, and process 4 to 5 is constant volume heat rejection. Process 5 to 6 is constant pressure exhaust stroke. Now let's calculate the efficiency of diesel cycle by using this formula. Then we will get 1 minus Q output by Q in, and we are getting heat output at constant volume, so we will get CV T4 minus T1, and for heat input at constant pressure we will get CP T3 minus T2, and this ratio between CP and CV as K, so we can write CV upon CP is equal to 1 by K here. Then we will get efficiency as this, and now when we will take common T1 from here and T2 from here, then we will get this relation. Now as you can see, higher efficiency is obtained by adding less heat per cycle. In diesel engine, the fuel cutoff ratio depends on the output maximum for maximum output. Now let's see. So in the diesel cycle, we will get efficiency as this, and by putting all of these values, we can calculate the efficiency of diesel cycle. So guys, for diesel cycle, please remember this graph between plot between pressure and volume. Now let's start with dual cycle. So the heat input process of combustion is approximated by a dual process of constant volume followed by constant pressure. So here guys, in this dual cycle we are getting heat input at constant pressure and at constant volume, but we are getting heat output at constant volume. So that is the difference between dual cycle, diesel cycle and Otto cycle. So how we can calculate the efficiency of dual cycle? So here we have to use this formula, 1 minus Q output by Q in. We are getting Q output, heat output at constant volume, so we will get CV T4 minus T1 by, but we are getting heat input at constant volume and constant pressure, then we will get this relation. Now we can calculate, by putting all of these values, we can calculate the efficiency of dual cycle. Now let's see some comparison between Otto cycle, diesel cycle and dual cycle. So the first comparison, when for the same inlet condition, the pressure compression ratio and same heat removal, we will get efficiency of Otto cycle is more than the efficiency of dual cycle, which is more than the efficiency of diesel cycle. And in second comparison, we will get for the same inlet condition, here we are putting all the inlet conditions are same, the same peak pressure and the same heat removal, and here we are taking same compression ratio, here we are taking same peak ratio and same heat removal, then we will get efficiency of diesel cycle is more than the efficiency of dual cycle, which is more than the efficiency of Otto cycle. So we are getting these two relation by using two comparison. Now let's see the third comparison. For the same inlet condition, the same compression ratio and same heat addition, then we will get efficiency of Otto cycle is more than the efficiency of dual cycle, and which is more than the diesel cycle. So that is the relations. So guys, please remember, because question can be asked in SSC based on the comparison of Otto cycle, diesel cycle and dual cycles. So I hope you understood all of these points based on Otto cycle, diesel cycle and dual cycles, and what are the plots between PV diagram or PV, pressure or volume, and temperature and enthalpy. So guys, if you want to solve more multiple choice questions based on SSC, GATE or mechanical engineering subjects, then please visit robojala.com, and for more videos please subscribe my YouTube channel Mekujala.